Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. The structure shows a 6-membered carbocyclic ring, cyclohexane. Step 2. Identify all substituents and features on the ring. A. An exocyclic double bond is equal to CH2, methylidene group, on one carbon, making that carbon sp2. B. A bromine, Br, on the carbon adjacent to the methylidene carbon. C. A hydroxyl group, O, on the next carbon. D. A chlorine, Cl, on the carbon adjacent to the O carbon. Step 3. Number the ring to give lowest locants. The O group defines the cyclohexanol parent. Assign C1 to the carbon bearing O. Going in the direction that gives lower locants, C1 is equal to O, C2 is equal to Br, C3 is equal to exocyclic is equal to CH2, methylidene, C6 is equal to Cl. Step 4. Construct the IUPAC name, parent is equal to cyclohexanol. Substituents, 2-bromo, 6-chloro, 3-methylidene, exocyclic is equal to CH2 at C3. Full name, 2-bromo, 6-chloro, 3-methylidene. Step 5. Verify against the image. The ring has Cl at the top carbon, O on the adjacent carbon to Cl, Br on the next carbon, and is equal to CH2, exocyclic methylene drawn as a terminal alkene, on the carbon adjacent to Br. This matches to bromo, 6-chloro, 3-methylene exactly. No other connectivity arrangement is consistent with the drawn structure. Therefore, the correct answer is 2-bromo, 6-chloro, 3-methylidene cyclohexanol. The correct answer is shown on screen.